Okay, Jesse, we miss you. We hope you're doing well. Sorry, we picked up right in the middle of notes, and we're doing example 3. In order to prove this, I'm going to rewrite cosecant as 1 over sine. Which rule would I use to take the derivative of that? I would use the quotient rule. And if you're going to use the quotient rule says you take the derivative of the top, which is 0, times the bottom left alone. I'm just writing the work so that Jesse can see it. And then we're going to subtract the top, which is 1, times the derivative of the bottom. All over what? Sine squared. What does that simplify to? Take cosine of x over sine squared of x. Any idea how I might rewrite that? What step do we need to see? Thank you. Negative cosine of x over sine of x times 1 over sine of x. So, what is 1 over sine? Cosecant, so you can see that's your cosecant. So everybody sees your negative sign, right? You see the cosecant, and then cosine over sine is cotangent. So this is negative cosecant of x, cotangent of x. Done and done. I'll smile if you write it. I'll smile. I'll say, oh, my brilliant little mathematicians. You know, I guess you guys aren't that little. You're 16, 17, 18 years old, somewhere around there. Okay. So, let's now go to work and utilize something else here, okay? So, what's that? Oh, utilize. Utilize something else. Alright, so now you learn how to prove something, okay? You've learned how to use the sandwich theorem. Now let's put some limits to work in order to evaluate other limits. Limit as theta approaches 0 of sine of 2 theta over theta. What does that look like? That looks really similar to that, right? Now here, this is super important, guys. Everybody wants to see theta over theta. I want you to know this. If it was 2 theta over 2 theta, those are the same angles, right? So it would be 1. So if we had a 2 on the bottom there, then we could evaluate the limit. So what I'm going to do is I'm going to rewrite this as the limit as theta approaches 0 of sine of 2 theta, and I'm going to multiply the bottom by 2. And in order to maintain equality, I have to multiply the top by 2. Is everybody sees that this is still sine of 2 theta over theta, right? Okay? The laws of limits allow me to write that 2 out front. So basically this ends up being 2 times the limit as theta goes to 0 of sine of 2 theta over 2 theta. Now again, don't worry about the 2 theta over 2 theta. We could just substitute another variable like sine of x over x. I mean, it's the same angle, right? So what's this limit? Times 2 is? So your answer is 2. What's that? I can draw this 2 out front. Yep, it's fine. Okay. That was back laws and limits a month ago, so we could go over it. Okay, let's try another one. See if you see it after this one. Everybody, instead of a, is it easier to change the 3 theta on the inside there, or is it easier to change the 5 theta? It's easier to change the 5. So, what we would like to do is, instead of seeing a 5 there, what would you like to see? A 3. So here's what I'm going to do. I'm going to write sine of 3 theta over 3 theta. Okay? What did I pull out here? I pulled out the 5, right? Okay? I pulled this 5 over here, and I multiplied a 3 on the bottom. So then we have to multiply a 3 on the top. It's 3/5. So, if you see it, all I've done is rearrange some of the numbers. So I've limit as theta approaches 0 sine of 3 theta over 3 theta. What is the limit as theta approaches 0 sine of 3 theta over 3 theta? 1. So you have 3/5 times 1 is? What's that? What's that? Okay. Can't just pull a theta out of the bottom. Doesn't work like that. Now, here's something important, people. I want to show you. Go up here and write this. Limit as theta approaches 0 of theta over sine of theta also equals 1. If the original function is 1, then the reciprocal is also 1. And so the limit as theta approaches 0 of theta over cosine of theta minus 1, that's also going to be 0. So you can flip them upside down and they're the same. So let's look at letter C then. Now you have a sine of theta on the bottom, don't you? And it would be nice if you had what on the top? Yeah. Well, it looks like it's undefined right away. So you're absolutely right. If you plug in 0, it's undefined. But you also remember that you can have a function that is undefined at a spot like this, but the limit still exists. So these have what we call removable discontinuities, but the limit still exists. Okay? So, cosine of theta minus 1 over sine of theta. If you see a sine of theta on the bottom, what do you want on top? A theta. Just a theta. Look. Yeah, look, you guys. You want a cosine of theta over or minus 1 over a theta, right? So I'm missing a theta on the bottom, aren't I? Well, look. You want this theta on the bottom. And furthermore, if I have a sine of theta on the bottom, I want a theta on the top. Very good, Larry. That's what we're going to do. Limit as theta grows to 0 of, here's what I'm going to do. I'm going to multiply, as Larry said, theta over theta times cosine of theta minus 1 over sine of theta. Is it okay to do that? So now what I'm going to do is I'll just rearrange it so we see it so clearly. The limit as theta goes to 0 of cosine of theta minus 1 over theta times theta over sine of theta. Very good. The limit of this is, and you get, isn't that cool? Okay, last one. I don't see a cosine or a sine here on top. That worries me. So what might you want to do right away? Let's rewrite it so instead of cotangent you have... Alright, so we have the limit as x goes to 0 of... Oh my gosh. No. I gotta show you two parts. I didn't realize this. You know what the cotangent of 0 is? It's undefined. That's why it doesn't work. But what is the cosine of 0? 1. So it's the top that makes it undefined, not the bottom. So just always make sure, we never want to plug it in because we're like, oh, it won't work. Don't forget, sometimes you can just plug it in. In this case, it's undefined on the top, not the bottom. Well, you'll see that come out in the end, yes. All of them are undefined. All of them have issues. So, we'll take Larry's advice. We'll multiply by the reciprocal. I now have the limit as x approaches 0 of cosine of 5x over sine of 5x times 1 over cosine of 2x. Is everybody okay with that? Now let's just think about it, everybody. Is it okay to plug in 0 here? Yes, because the cosine of 0 is 1. But if you plug in 0 here, you get what on the bottom? 0. So, let me ask you, if you have a sine of 5x in the denominator, what do you want in the numerator? A 5x. I mean, if we got a sine of 5x here, I want a 5x in the numerator. So you're going to multiply the numerator by 5x, you got to multiply the denominator by 5x as well. Okay? So, here we go. Limit x goes to 0 of 5x in the numerator, 5x in the denominator, times cosine of 5x over sine of 5x times 1 over cosine of 2x. So we have the limit as x goes to 0 of, so I want to pair this 5x up with what? Sine of 5x. Times cosine of 5x over times 1 over cosine of 2x. What is this limit? What is this limit? What is this limit? Can you plug it? This doesn't fit our identity, does it? And if you plug in 0, you get something undefined, don't you? I bet I wrote a bogus problem. Sorry, I'm going to have to look at it further. I thought, no, you guys got to understand, the first time I did this, first time I taught this lesson, all 4 problems, I did it right correctly. So then I went back to next year and I changed them all. I wonder if I still made a small mistake there. Oh well. Well, no, you saw some of the good approach. I don't know. I'll have to take a further look at it. Yeah, he literally made up. Okay, there's the assignment. Good luck. First section is the sandwich theorem. Second section is what we just did.